picture of what's the global installed capacity. Right, I have asked a question about India, but this is the global capacity, right? So for an Indian perspective also I will go, but this gives you an approximate idea of what's the installed capacity across the globe. So as on today, we have installed 650 gigawatt, that is 6,50,000 megawatt is what's the installed capacity we have across the globe. That is the data of 2019. That's fine. So in Indian data, let's closely look into the data. I mean, it's not probably from the slides. Let me go back to some websites to take up some setting. Means what's the installed capacity? Yeah, I mean, this you might be aware of this website. This is a CA website. You just Google it with CA, you will get it. So I have opened that website already because of might be sometimes poor internet connectivity may result in some disconnections. So CEA, if I am going to the CEA, and I mean, so to say, if you go to the report, the page will open, right? That's what as I told, the page may take little time. So if you go to the installed capacity, if you go to the installed capacity, means May 2020 data is yet to get updated, probably will update it in 2 or 3 days. So if you go to April 2020, you can look at what's the installed capacity in India as on 30th April, that is about a month back data. So total installed capacity is 370 gigawatt. That's what somebody has rightly put up. This is 3,70,000 megawatt is the total installed capacity in India as on April. Okay, today means we are in June, but we don't have much additions because of the lockdown. Okay, out of this 370 gigawatt, about 87 gigawatt comes from renewables. But if we quickly go to the wind, more specifically, somebody has again put it at the right value. In India, the wind installed capacity as on 30th April is 37.7 gigawatt is from wind. So if you compare the percentage, approximately wind is slightly more than 10 percentage, right? So let me take an Excel sheet as well, because we might be using Excel sheet quite frequently to calculate some informations here and there quickly to calculate the percentage or a payback period. Yes, so I mean 37.7 gigawatt out of 370 gigawatt, obviously that is slightly more than 10 percentage. That's the number. Okay, so let's I mean, so let's say look at this figure also. Solar power. Solar power is on the same day, that is 30th April, that is 34.8 gigawatt. Means why I am stressing this, because I mean, so to say, I'm just comparing the growth rate of this wind along with this solar. So means let's take a data of 2017, same April data. April 2017 we will take, and we will try to take means both solar and wind, and we will compare both the data, right? So let me take 2017, 2018, 2019, 2020, right? Let's compare. I believe this Excel sheet is visible for you. Let's compare wind and solar. So I mean, so if you look at wind, means we have 37.745 gigawatt. Let me put it in gigawatt itself, that is wind. Solar, if you look at 34.881, 34.881, right? 34.811, right? So installed capacity is 370.347. If you look at wind in percentage, that gives I mean slightly more than 10 percentage, as I told, right? This is wind in percentage, this is total, this is wind in percentage, solar in percentage, right? So if you look at solar, yes, so wind is about 10 percentage and solar is about 9.39 percentage, that is almost close to wind. But I'm just comparing the past history data to understand how it is growing, this both renewable sectors, wind and solar. So for that I have taken a 2017 data. I haven't done anything special here. I mean, what to say, here you can find out 2020, right? I mean, what to say, you just change this 2020 and I mean, what to say, just change it to 2017, you will get 2017 data. That is 30th April 2017 data. That means I am just going back to I mean, what to say, 3 years back. Look at the installed capacity, it is 329.118, right? This is 329.118, and solar is 122.88, and wind is 32.279. So it is 12.288. Sorry. So let me copy this everywhere to find out the percentage. Right here the data is missing, so that's the reason it's not coming. So probably means you can put this data, change this data to say 2018 and 19, you will get the data. But even before going for it, we can easily understand from the what's the data which I have entered as of now. 343.798, 343.798, right, and 21,651, and wind is 34,046. Yes, so 2019 also I will put it. I am just changing the year, that's it, nothing more. So the data is available, that's what I am trying to say. So 356.100, 28.18, and wind is 35.625. Yeah, it's absolutely clear. So means what's the growth rate of wind, what's the growth rate of solar, right? So 2017 we had 32 gigawatt of wind, that is 32,000 megawatt of wind, whereas we have only 12,000 megawatt, 12 gigawatt of solar in the year 2017 April 30th April 2017 data. That means by the time we have almost about a 10 percentage of wind in the total installed capacity of 329, and I mean solar we had about only 3.73 percentage. Just I am not comparing long back, I am comparing only about 3 years back, right, 2017 data. But if you look at 2018, means 32 to 34, that means just 2 gigawatt has increased, merely 2000 megawatt, but solar has increased about 9000 megawatt or 9 gigawatt. And probably if you compare from 18 to 19, I mean, so to say, it is just merely 1.6 gigawatt, just 1600 megawatt. And I mean, so to say, whereas solar has grown about 7 gigawatt, 7000 megawatt. And I mean, so to say, if you take further on the year 19 to 20, so probably approximately again 2 gigawatt, that is 2000 megawatt. But if you literally take the wind, sorry, solar is growing about 6 gigawatt. Right, if you look at the percentage is almost steady and slow. I mean, it's in the range of means it's 9.8 percentage. It has increased to 10.19 percentage in the year 2020, that is in 3 years it has grown about 0.4 percentage. But if you look at I mean solar has grown 3.7 percentage in 2017 to 9.3 percentage in 2020. That means that's an amazing growth. So this gives you a very interesting information of what's the sector which is growing, correct? So today I'm talking about wind. That doesn't mean means I have to promote a wind. This is where the actual reality which we stand. We could find a number of reasons why means what say the wind is not growing. That could be the reason because a few people say means the already entire energy which is available in the wind is tapped, etc. We will means go a bit more on that aspect as well. But at least this information what I have conveyed is pretty simple and straightforward. It gives you the data for the last 3 years, what's the total installed capacity, and if you can look at means year by year how much percentage it is growing, right? So that's also means other interesting factor which you can see. I mean, if you look at how much percentage it is growing, yep. So So means what to say, the total installed capacity is growing by about 4 percentage from 17 to 18, and 3 percentage in 18 to 19, and again 4 percentage in 19 to 20. This is the data which I am comparing from April 30th, April 30th, April 30th. But probably other data what you might be seeing in some newspapers or something might be slightly different. That's because they might be using a calendar year. That means they compare on December 31st. This is also you can very well take the data if you want December 31st, which you can very well take, right? And if you look at the individual growth, yes, so means what to say, wind is means what to say, growing at a rate of about 5 percentage or a 4 percentage on a year from the installed capacity perspective. But if you take solar has grown means drastically, probably from year 17 to 18, but that growth rate is means what to say, reducing over the period. That's all few key takeaways which I want to put in before I am concluding. But yes, So if you want the data of means what is it, December 2019, means you need not to do anything, means 4th is April, you just change that to 12, that is December, you will get a December data. So that's how you need to get the data from this, right? Perfect. So yes, Madhavi Mohan, solar energy has a good results. Of course, I mean, so to say the growth rate is much better for a solar than compared to the wind. That yes, you are right, Madhavi. Fine. So let me go on to means interesting website. We have a National Institute of Wind Energy, right? I'm going to their website. So to talk about few statistics and informations, right? So means this probably you might be aware. This is available in Chennai, National Institute of Wind Energy. So here they have given quite a lot of technical informations, probably in the what's new, which you can ask. Yeah, India's wind potential atlas, that is at 120 meter, right? I'm opening that data, right? Even offshore radar raw data is available in .sta format or .rtd format, right? Let me also talk about there is an interesting project which everybody is talking about, right? That's on means what to say, wind and solar combined projects in the Ladakh region. There is some assessment PPT also which they have said. So I will talk about this three before I'm moving forward. Yes, it might take little time because of the internet connectivity, but that's fine. Okay, so they have, I think it's taking a bit of time. Let me check whether other pages are open. Maybe I have opened quite a lot of pages. That might be the reason why it's slow. Let me close it. But anyway, CA website, I think it is a bit straightforward and clear from the website. And this data is available from state-wise also. Probably if you go to, I mean, state-wise data is also available. Right? If you want to look at Tamil Nadu, probably the south, you can find it. Yeah, Tamil Nadu, what is the installed capacity of different sources, coal, lignite, gas, diesel, all these informations are available. Anyway, I'm not going to talk on that, but that just for an information. Yes, I'm closing all this. Yes. So wind and solar resource assessment, this is in Ladakh region, which NIWE has done recently. And probably this is more relevant when I'm going for some simulations in Homer today to just show what is the capacity utilization factor, right? So means they have assessed the wind and solar capacity in the Ladakh region in Jammu Kashmir, right? So they have given the area where they have measured it. So means what to say, height of the mast, and they have identified what's the mean wind speed, right? So if you look at the mean wind speed, even some places the mean wind speed, that is an average wind speed, is about 6.6 meters, right? So you can have a different height of the mast, and you can see what's the average wind speed, right? This is Ladakh and it's Kargil, right? So you can have a data of 1 year data, that is Jan, etc., etc. Then even I have really wondered, because when I'm going to the simulation software, means what, see, all these data will be directly imported from an internet, that is the data from NASA, or that is the data from NREL, etc. Then I have really wondering why this NIWE has done this analysis. Then probably later I have understood, I mean, so to say, these are the actual measurements, whereas what's the data which NASA or NREL is giving, that is the satellite based measurements. So what's the data which NIWE is providing is more accurate when you are assessing the capacity of this wind turbine generators. That means this is an actual measured data based on their means what to say, wind mast which they have put up to install to find it out. So their quick takeaway is probably it's clear, means their capacity utilization factor could be as high as 25%. So you might be asking, what is capacity utilization factor or a plant load factor? So if I am installing 1 megawatt wind turbine generator, that will not generate 1 megawatt continuously. Am I right? If I am installing 1 megawatt wind turbine generator, that will not generate 1 megawatt continuously. Simple reason, because wind will not be constant and the wind will not be at rated wind speed, right? So the wind will be fluctuating and sometimes wind will not be there. So the wind turbine generators will not be able to generate means the 100% of the power on a 24/7. So the power output from the wind turbine generator is intermittent. So if you find out what's the average power generated by an installed capacity, that gives the capacity utilization factor. So capacity utilization factor tells how much energy which we can extract from the installed wind plant. So this is not necessarily applicable for wind; it is applicable for all the sources. So the capacity utilization factor based on their measurement can go as high as 25%, right? So then probably I'm going to the next one, wind turbine generator 850 kilowatt. So they have taken some data from location. They have given x direction, y directions, elevation. They have given, right? What's the energy potential? What's the loss? Means what's the energy which you can tap? What's the average capacity utilization factor they have given? So it's clear. So means you can either go with means this 27 percentage capacity utilization factor or 24 percentage, that depends upon whether at 50 meter or at 90 meters, right? Wind potential they have given conclusions. It has a good wind resource at 50-meter hub height, the estimated potential, and at 120-meter height, this is the potential. Okay, so probably if you look at this, capacity utilization factor is slightly higher at 50-meter height, and it is slightly less at 24-meter height. But you can look at the difference in the capacity, right? So at 50-meter hub height, the estimated installed wind potential considering the sloping and land constraint in that particular area is just 5000 megawatt, 5300 megawatt. But if you go with 120 megawatt, 120 meter hub height, removing the slopes, altitudes, and the other land constraints, the potential is, you can see, it's 100 gigawatt or 1 lakh megawatt. So means even if you have looked at the previous capacity, total India has as on today installed capacity of only 370 gigawatt, but Ladakh region alone has 100 gigawatt potential of wind at 120 meter hub height. So that gives a rough idea. And as on today, what's the installed capacity of wind is, we have seen, that's right, about means 37 gigawatt. But whereas compared to that, means we have a 100 gigawatt potential in the Ladakh region alone at 120 meter height. So this is giving a very good idea. Means probably if you have looked at this, you might have confused. Means you might be thinking about to go ahead with the 50-meter height because the capacity utilization factor is 27. But if you go with a 90-meter hub height, then this is at 24%. Then probably you might be thinking to go for a lower hub heights. But this is the really means factor which you need to consider. That's where you have a high potential, right? So proposed locations and the measurements, I believe this link is also available. I have just opened it from website, so means you can just go through to understand it. I'm not going through all points, but they have given just not wind, they have given the solar measurement also. That means if you put up say assume solar plants, it occupies quite a lot of area. So means in the same area, if you put if you have wind, then that definitely has a means very good combination. Yes. So means in that region they are concluding the solar energy capacity utilization factor is about 22%, and wind is about 25%. And cumulatively, if you go with the wind and solar, then definitely you can go with more than 45% capacity utilization factor. That's really a massive number, which means that could be the understanding, or that could be the outcome of what's the assessing this wind and solar potential. That's what NIWE is doing. Thanks for Kadiravan joining from NIWE and looking at done. Fine. So India wind potential atlas. That's again from the same NIWE website, which is available. So you can go through this data also to understand means what's the capacity of wind turbine which is available. I am not going to all this, but one interesting information is the total wind power potential at 120 meter height is about 700 gigawatt. Means as on today, our installed capacity base itself is only 370 gigawatt, right? Total installed capacity including our sources, and wind is only 37 gigawatt. But the wind potential available in India, total wind potential at 120 meter height is 695 gigawatt. That gives you a means approximately what's the potential wind has. So this is the wind power potential at 120 meter height in a wasteland, and it is a cultivable land and probably the forest areas. They have given total. At least in a wasteland, if you go, you can still achieve a potential of 340 gigawatt. Fine. Yep. Slide is not clear anyway. I'm not going much on the slides. I'm just going with some websites. So probably I will just post it the links in the chat box, so you can just very well take it out and really, yeah, probably if you go to the NIWE website, you will be able to find all. So yes, I could understand. Yes, I mean, you may not be able to read with that PDFs or the numbers which I am showing, but probably I have shared the links which you can take it up and you can really go through it even after the session, right? So state-wise detailed capacity they have given wind potential at 120 meters. So look at that, Andhra Pradesh, Arunachal Pradesh. I mean, what to say? That's the potential what we have in means megawatt, right? So this is with the total installed, means total wind potential what we have. If you look at Tamil Nadu alone, yeah, Tamil Nadu has about 68 gigawatt of wind potential even now. So 68.75 gigawatt of wind potential as on today. Right? Means already we have talked about what's the capacity of wind turbine generators in India, which you can really go to another website, SRLDC, Southern Regional Load Dispatch Center, right? To watch it out. And I'm going to that website also for another important information to showcase means what is the what's the installed base and how much energy which we are generating from that. So I'm just going to the SRLDC website, Southern Regional Load Dispatch Center. Similarly, you have north, northeast, west, and all load dispatch centers, and the frequency is there. That's the current frequency at 11.8 or 11.9, which we have now. So I'm just quickly going to the information reports, daily report. I'm just checking the yesterday data, that is 3rd June data. This data is available for the past maybe 14-15 years data on a daily basis, which is available, right? So means the information what I am going to share is directly available in website, because I'm also taking this information from website only. I'm putting that link also probably. So you can use it. Yes. So yes, I could understand. Means the slide is not clear because that I am showcasing from the directly from the websites. I have shared the links in the chat box, so probably you can open that links and probably if you want you can use that. That's also a ready reference for you. Means what is it? Even after the session, right? So let me go to the yesterday data. Means it is not the only data which you need to look at. You can go with any other data as well. As I told, means you can very well go with means last 16 years data from 2004. Any single day data is available on a daily, weekly, monthly, quarterly, all basis. So I'm just looking at the yesterday data. So I have gone for a daily data. I'm trying to showcase, I mean, what's the installed capacity and what's the plant capacity utilization factor on yesterday data, right? So here, if you look at Tamil Nadu, yesterday Tamil Nadu has generated 83.37 million units, 83.37 million units from thermal, 8.78 million units from hydro, 7.84 from gas, naphtha, diesel, and 37 million units from wind. So that's what I'm looking at. Means wind yesterday Tamil Nadu has generated about 37.09 megawatt wind. I mean, whereas solar has generated about 18.2 million units. So first, probably let me come back to this Excel sheet. I believe at least Excel will be useful. You might be knowing what is 1 unit, correct? At least thanks to the recent electricity bills, right? Yep. So kilowatt hour, 1 unit is 1 kilowatt hour. That means if you put up 1 kilowatt load and if you're running that load for 1 hour and if it consumes 1 kilowatt hour, then that is 1 unit, right? So what is the energy which is generated by a different source? Means what is the 37.09. I'm not really interested in other things, but I'm worrying about 37.09. This is million units. So in order to convert that into units, let me multiply by 10 power 6. Right, that gives me what's the total kilowatt hour which has been generated by the wind, right? This is the wind, which is the yesterday data, right? This is a kilowatt hour. So then probably let me look at the solar as well. Solar is 18.2 into 1 e power 6. That is the yesterday data. This is data only which I am talking about. Uh, about Tamil Nadu, right? Similarly, you have all other data, and probably if you go to the CEA website or if you go to the POSOCO website, you can see the entire Indian data, right? So other website, like if you look at Power System Operation National Load Dispatch Center, you can have a daily report here. That daily report gives you, I mean, the complete data, right, for the entire country. So I am just comparing, I mean, it's only for a from Tamil Nadu perspective, right? So wind has generated about 37 million units yesterday, and solar has generated 18.2 million units. Let's try to find out what's the capacity utilization factor or plant utilization factor of this. Yes, for that I need to take Tamil Nadu. Yes, so I am just looking at Tamil Nadu, and what's the installed capacity of wind? Wind installed capacity is 8488 megawatt, 8488 megawatt wind, and 2663 megawatt solar. Right, this is megawatt installed capacity. This is kilowatt hour, right? That is for the whole day. So if I want to, I mean, what to say, convert this into plant utilization factor, then means there is an average generation divided by installed capacity. So I'm putting an average generation. So this is average megawatt. So if I want to put it in megawatt, then I need to divide by 1000, and that is for a 1 year data. So I'm dividing that by 24 hours, right? So that gives what is the average generation, right? So what I have done, this is the total energy generated in kilowatt hour. I am trying to find that into convert into an average megawatt generations, right? Because average megawatt divided by installed capacity directly give me capacity utilization factor, right? So this one, if you are looking at, then what's the yesterday plant capacity factor or capacity utilization factor is about 18%. That is the wind data yesterday, right? The same thing which you can do for solar as well. Yes. So I mean, if you look at compared to that, if you look at what is the solar data is about 28.47 is the plant capacity factor. This is only with respect to I mean Tamil Nadu. That is only with respect to the I mean yesterday's status. Similarly, you can put up this data probably from different days, months, weeks, or periods. Like if you take Tamil Nadu, means we have some wind period, right? There, this plant capacity factor could go as high as maybe 43%, but during non-windy seasons, then they could be quite less. So this you can use it because this data is, as I told, it's available for the past 24 uh, past at least 16 17 years, but the data what I'm putting is this is the capacity utilization factor, which generally people call CUF or plant load factor PLF. I mean whatever the way which you want to cover. So yeah, please analyze the data for Delhi also. Yes, I think probably the data is available for you. You can take the data. So I am just given for a Tamil Nadu simple reason because I mean that's I mean which I have taken. But this is SRLDC data. You can look at all southern states here. Similarly, if you want other states to be compared, you can very well compare using your north load dispatch center or east or west, depends upon where you want. So I leave it that to you, and probably means what to say. If you go to this website, the POSOCO website, and probably means this gives much beautiful information on this COVID, all this data, loads, how much renewables, etc. on daily reports. Even renewable, they have a separate means what to say page which you can watch. I leave it to you to do that exercise, right? Fine. And if you have any questions, which probably if I can answer, I can answer it. Yep. I don't think I have received any questions. Yeah, I think only one question so far which we came across is what about floating windmill? I'm not sure. That's a question from Susiri Anubhuti. That is to asking about offshore wind or not. So means anyway. So probably I like. Means if your question is a bit more clear, then I can take up that question probably at the end of the session or at least by tomorrow. Right. So let me move on. Right. So this has given some idea what is the installed capacity in India. So we have talked about global. We have talked about Indian perspective. right? So I believe this I have talked about installed capacity in India for last few years, right? So yes, this is the data of the highest or largest wind turbine generator. This is 12 megawatt single in largest capacity, right? This is having a 220-meter rotor, 107-meter blades, totally 270-meter high, and probably it will be able to generate 67 gigawatt hour energy, that is 67 million units of energy from a single generator. And they are claiming that is 63 percentage capacity factor, means we have now worked out it is about 15% or 20 percentage, means this in an offshore it can go up to 63 percentage capacity factor. That could be means almost comparable to your conventional sources, right? It means if you take thermal power plant, the capacity utilization factor is in the range of about 80 percentage to 90 percentage. So here I mean what to say, with this large capacity offshore wind turbine generator, you can go ahead with means up to 63 percentage which they are claiming, right? So what's the swept area? I mean some data which is available. Anyway, I will share the slides which you can I mean sort of say refer for this, but you just Google it, you will get this information. There's the data which is available in website itself, right? Now means moving forward, you can just compare the heights also which they have given, right? Means what to say, your height is 260 meter, which is I mean it's almost comparable with all the tallest which you're looking at, like either it's Eiffel Tower or I mean highest building, right? But yes, this is another interesting fact, whether you are looking at the wind turbine generator onshore or whether you are looking at the wind turbine generator on offshore, right? So this I believe has given you an idea. I mean, so to say, the what's the previous one which you have seen is like mm, means what to say, offshore means you can probably comment now what's the highest capacity onshore. Yeah, Harish, we will share the slides with the organizers. They will in turn share for all the registered participants. And there is a question from Dr. Pandian. What are the challenges in synchronizing with the grid? Yes, that's what the probably topic which I am going to deal in detail tomorrow and day after tomorrow. Yes. So over the period, definitely I will take up that question. So means what to say, this are all basics which I am not really means want to stress my time much, but this is like what are the equipments which are there in your wind turbine generators, right? Definitely you have a generator, you have a high speed shaft, you have a nacelle, you have a wind van which is in the I mean what say behind, and there is an anemometer to detect your wind speed, and wind van is to find out what's the direction of the wind, and yaw mechanism or yaw motor is to turn your wind turbine generators towards to face the wind, right? And brake to apply, and pitch systems to control the blade, so that I mean so to say at what angle that wind has to hit your blades, and wind direction that's coming from normally flowing, right? That's the blades, rotors, right? And of course then you might be having a step up transformer, then the grid, correct? The transformer is here and you have a step up and you are pumping to the grid. Yes. So there are something which I am not going to really spend about it, but I could refer a good website for that. Means for a data, means all theoretical aspects can be covered in one website. So probably means what to say, if you put Danish Wind, that they are means what to say having all the theoretical data which you will get it. I strongly refer. So probably means with an animation you can find out what is the pitch control. If you want to see what is animation, yaw mechanisms which you can see. So means I'm not going to read out all this. The data is available which you can go through, and that's quite easy as well. So if you want, I will means what to say copy and paste that also in our, might be my video resolution is a bit poor, that might be the reason you are getting. Okay, fine. That anyway, I think I can go back to my slides, right? So these are some theoretical concepts which I'm not going to discuss. I have shared a link which you can really watch in that link. That is a Danish Wind Energy, where you can see yawing mechanisms, pitch control. For all that means you have a very good write-up, as well as you have a I mean videos, images, animations, everything, right? I'm not going to all about this, but you can look at this pitch control. I have taken from the same website, Danish. but yaw control I had some other good information from GE website, so I have taken that image from Z. So you can understand means how this yaw mechanism works. Yaw mechanism turns the nozzle towards to face the wind, right? Means if the direction of the wind is from east to west, and if it's changing from say example south to north, then probably this means what to say, wind van which is there here, I mean detects the direction and it gives the control via controller to the yaw motor to change the direction so that the wind blades can face the generate wind, so that it can generate more power, right? So I mean, so what say, this is a power curve which you can talk about. Let me put the full stop for all and I will go for a simulation. Before that, I will just talk about only 3 or 4 terminologies, right? One is cutting wind speed. That's the minimum wind speed at which the wind turbine generator can start generating power. Means this cutting wind speed doesn't mean it will be able to generate rated power. Please understand that cutting wind speed is the minimum wind speed at which you are able to generate some power. That's it, at least some power. Below this speed you will not be able to generate power at all. That's out of operation. And from cutting wind speed to rated wind speed, you can see means what to say, with respect to the increase in the wind speed your power is increasing. So means what to say, approximately your rated wind speed will be in the range of 14 meter per second, which you can refer the data sheet. I will probably means what to say, share some links of different manufacturer wind turbine data sheets that you have to watch. Okay, means approximately here we are rating means reaching the maximum capacity at 14 meters per second, and after that the power output is constant. So means what to say, they are comparing two things, right? One is a pitch regulated wind turbine generator and other one is a stall regulated. Stall regulated is bit old, now everyone is using pitch regulated, right? So means after that you can see means what to say, the power output remains constant, and pitch regulated you can see the energy which I am extracting is high, that is a red line compared to the blue line, right? And after 25 meter per second, I mean, so to say, you cannot generate power. That's because of so the constraints on the mechanical side, and it's the stability. That's a physical constraint. So means after the wind velocity goes beyond 25 meter per second, you will switch it off the wind turbine generator to safeguard the wind turbine generators. And one important information which is missing here is like a surveyable wind speed that is approximately in the range of about 67 meter per second. So that means even if you switch off your wind turbine generator, if the wind speed goes above 67 meter per second, then you may not be able to safeguard your wind turbine generator systems, right? So these are all I think clear. Fixed speed, variable slip, and doubly fed full converter, etc. Means I am not going to discuss more on it. Probably means this I will take it up as with a simulation, how a fixed speed wind turbine generator have an impact on the power factor, voltage, real power generations, etc. Similarly for a variable slip, doubly fed, etc. I will take up with a simulation tomorrow. In addition to the power quality, I will talk a bit more on the what to say, about power factor, voltage, equipment loading, losses, short circuit, everything I will discuss maybe tomorrow. I am not going to discuss all these theories which you might be aware, which is available directly in the textbooks, right? So this you might be very interesting fact which you might be aware, right? Means Tesla has installed a 100 megawatt 129 megawatt hour large battery energy storage systems in southern Australia. That is means what to say, firming up the power from the wind farms, right? I mean, so what to say, there is a huge intermittent resource, heavy penetration which is there. So means to support that, means they have included a large scale battery energy storage system. Yeah, Abhilash Naik, there is a question. Will not the wind turbines face the damage on the blade structure when it is switched off after crossing cutout wind speed? The answer is yes. So for that means what to say, where you need to change the angle of the blade so that the blade will not see the wind, right? So you have seen some pitch control, correct? You can go back to the Danish Wind Energy website and you can check how it functions. So means after 25 meter per second, means what's the wind velocity, that generator will be switched off. There is no doubt about that. But means his question might be like the wind velocity is still there. That has an impact on that. So that definitely taken care by default by changing the blade angle, so that means what say, the blade will not face the wind, but instead of that the wind blade is almost means what to say, at the same along with the wind. So means the blade will not see the wind. Right? Yeah. Fine. These are the issues which I am going to talk about. Maybe not today, but tomorrow and day after tomorrow. If you feel anything else to be included as a part of this tomorrow and day after tomorrow sessions, please please feel free to means what to say add your uh, questions. So I thought of discussing about voltage profile, equipment loading, losses. These are all with respect to the load flow analysis using ETAP. Short circuit level, that is again using ETAP. That is tomorrow which we are going to discuss. Stability, I have means what to say dedicated one session on Saturday, that is for purely for a stability, that is using DIgSILENT Power Factory, not ETAP. So I thought of touching the significance of the software DIgSILENT Power Factory's importance, so that you will learn other software as well. Yes. So, and power quality, that we are going to discuss tomorrow along with the load flow and short circuit in ETAP itself. Protection, relay coordination, islanding, loss, load shedding schemes, which we may not be able to means what to say, we may not be able to really cover as a part of these sessions, but probably means we will come back for a separate YouTube session for this protection, relay coordination and islanding or load settings. That may not be, means we may not be able to cover that. Yes, so I think any other questions which I am looking at? Yeah, feedback link. Feedback link will be definitely shared maybe at the end of the session. Okay, still we have means 30 more minutes, I believe, so you can bear with me. I will share the feedback link probably around the range of 11:50 or something. Yeah, PPT definitely will be shared for the registered participants. Abhishek Nayak, no, the blades will not rotate. Uh, so, so probably means I will come up with some videos tomorrow so that you will be able to better understand this. So means what to say, the blade is now facing the wind, which will be turned 90 degree, so that means the blade will not face the wind. So that means what to say, when the after the wind speed has reached beyond 25 meters per second, you will just not switch off your generator. You will not allow your generator to run in a freewheeling mode. That's what you are calling like. Blade is rotating but generator is not connected to that, so that's not the case. I'll come up with some videos where you will be able to easily understand rather than I am just explaining over that. That's to Abhilash Nayak. Yeah, PPT will be definitely shared, there is no doubt about that. Okay, anyway, I am going to be there for tomorrow as well as the day after tomorrow, so definitely that will be there. And Shankar Manish Patil, yeah, please upload the PPT for all the sessions on our website. Yes, yes, we will do that. Actually, means what say, to be very frank, we have never ever updated our website. That long time pending. Definitely, we will do that. Okay, we will try to consolidate all and we will add that. And sine loop, synchronous wind turbine with a three-phase grid detail. Can you please include this? Yes, that's what we are going to discuss on day 3. Okay, so probably means day 2, that is tomorrow, we are going to discuss about means load flow or short circuit, everything on means what to say, per phase analysis, but that's because all balanced system is what we are going to assume. But on definitely on day 3, that is when we are talking about means what to say, stability study, definitely we will include 3-phase model. Yes. How we need to register for this, so probably means someone, those who have a link to register it, they can post it. So for this event is organized by SRM University with the Institute of Engineers Cotton Clothur campus, and we are just a technical partners providing a session here. Okay, if you want certificates, everything, that means what to say, there is a registration link that you need to follow, Swati. So I mean what to say, I will try to put up the registration link today, means along the sessions. Okay, I have to check whether I have it live or not. So means what to say, you have to register through that if you want to get certificates, everything. Means certificate will be issued directly from SRM University along with IEA, right? Fine. So let me means what to say, go ahead. So there are the grid integration issues, but I'm not going for it. I'm going to directly software called Homer, right? This is where we talk about the economics, right? So means we talk about mostly as an engineers, we talk quite a lot on the technical perspective, but we fail to miss some really interesting, important commercial perspective, right? Means there is no point in talking about LVRT or low voltage right through or high voltage right through, frequency, harmonics, stability, everything, if the project is not potentially or commercially viable. So that's really important. So that's what we are going to discuss for about mm, uh, I mean what to say, next 30 minutes, and I believe it may slightly go higher time than what I expect. Okay, So the link, registration link, I will definitely put it. Okay, fine. Yeah, yeah. So let me go ahead. The software is available for free. I mean for 21 days. Okay. So the software which I am going to talk about is Homer Pro. Means you don't have a Homer Pro alone. You have a many softwares like Homer Grid. There are many softwares are available. This is a website. Okay. Probably means if you go to the websites at the last, in the bottom most, right, you can download about 21 days trial version of the software. Okay, so yes, those who came directly to our website, please register with the college link, which I am going to probably share maybe today or tomorrow, right? Fine. Yeah, some questions on the insulation coordination. I don't think we will be able to take it up that. Definitely we will organize a separate session for an insulation coordination query, right? Fine. Yeah, right. So let me go ahead with the software. So means what to say. But before that, means you have a software link which I have said. You have an option to download the software and you can practice the software what we are going to teach today. Right. So the software is this. Right. Let me take a new project. Yes. Because of link, it may take a little bit time, but yes, it's really worth investing time on the simulation software, because this is a software which we have least touched also in our simulation classes. Means what to say, if you take some simulation softwares like PVsyst, that is applicable only for a solar power plant design. But here if you take this Homer, you will be able to model whatever may be the sources which you want. So the software has a capability to model any kind of thermal, gas, diesel generators, PV, both PV and CSP, wind turbines, all kind of wind turbines, and means already the default libraries of most of the manufacturers are available. Storage, you can model all kind of lead acid and lithium ion batteries. You have bidirectional converters which you want, you can model. You can custom design your own equipments, boilers, hydro, reformer, grid, all these components which you will be able to model, right? If you take PVsyst, you will be able to model only the PV solar plant, but this software provides the flexibility to model all the sources. You can download directly solar radiation, wind velocity, temperature, hydro potential, biomass, everything directly from by means of giving a location, and you can download the data. And you can give a currency, whatever the currency which you want, like whether you want INR. Say example, if you want means if your project is in India, there is no point in doing the project in USD, so you can put it INR, and almost all universal currencies are available. You can model means here what's the rate at which you are borrowing the money from the bank for an interest, what's the expected insulations, what's the project lifetime. I believe I have asked the beginning of the session, means what's the lifetime of a wind turbine generator, right? So probably if you look at Tamil Nadu has come up with the wind turbine generators on 1990. So if you set means 20 years is a lifetime, means what to say, the lifetime has been already over in 2010. What we are doing with this wind turbines after their lifetime? So that's another question to be answered. I will try to put, take the answer for means tomorrow. Yes. Yeah, Homer Pro, that's a question to answer, Madhavi Mohan. Homer Pro is not necessarily for wind or solar, it's for all. So you can probably means what say in the component you have seen wind, solar, biomass, thermal, hydro, everything. So means only thing, the constraint of Homer is Homer will not be able to model your transmission and distribution losses, because you cannot model really transmission lines or cables. But apart from that, you can model all the sources and loads. Yes. So project lifetime, you can give what's the capital investment, operation maintenance cost, all these things you will be able to give, and you will be able to beautifully give a multi-year. Say example, in the sense means today I'm putting up a solar plant. The solar plant is generating some energy the first year. You cannot expect the same energy after 10 years or 15 years. So means over the period, what's the energy reduction? What's the loss of efficiency? Everything you can model for till the lifetime of the project. That's multi-year. And probably put it as sensitivity. Say I'm putting it this way. Say electricity price is increasing, say every year by say 3% or 4%, or diesel price is increasing or decreasing, or means what say the capital investment is changing, or operation cost is changing. So means what say you can play with some sensitivity, like means if diesel price is 8 rupee, sorry 80 rupees per liter, that is changing to say 85 rupees per liter, what will be the impact? All these stuffs which you will be able to means what to say model it here. Multi-year sensitivity, you can have an optimization, means whether you want to model minute by minute or 2 minutes, 5 minutes, 10 minutes, up to 1 hour, that you can model. You can model multiple generators, means whatever things which you want, probably the software helps you. Probably means if I talking about the software itself will take means what say more than a day, but means we will limit our discussion with specific to wind turbine generator, right? Yes. So let me remove all the equipments. Means how to start the project. First and foremost, you have to give the location of the project. So since the program which we are doing with SRM University, so I have just given SRM Katan Glatur, means this has identified the location. Probably means previously if you have looked at means what is it, the cursor was, the location was somewhere else, but now when I am changing it, it's automatically changing. So example, if I am putting up a project in London, yes, automatically you can see means what is it, my project location is changing. So assume I am going to put up a wind farm in SRM University Katan Glatur campus. Right. Yep. So perfectly precisely that identified the location. Yes, probably means those who are in the campus can really means relate. That's a perfect location. Yes. So what's the purpose of going for or selecting the location for the project is simple, because based on your location, your wind potential or hydro potential or solar potential is going to change. So selecting the location is the prime most important, and giving this data. What's the discount rate? What's the inflation rate? What's the annual capacity shortage? This is means what's the percentage of loss of load which you are accepting if you are a load centers, right? So what's the project life? Everything which you can do. So now let's model a grid, right? If I have a wind turbine generator, then I have to pump the power to the grid. So I am modeling a grid. So I am modeling a grid, means if I am purchasing the power from the electricity board, assume the same college campus I mean, what to say, SRM Katan Glatur campus receives the power supply at 8 rupee 5 paise per unit. That's a commercial tariff. So I'm just giving the same price of grid. And grid sellback price, if they are means what to say, generating electricity from some means, they can sell. That price is given. I have given it as a 3 rupee 50 paise, but that depends upon what source you are generating power, etc. So I have just given simply for purchase power cost is, that means if I am buying 1 unit from electricity board, that costs 8 rupee 5 paise, which I need to pay. Whereas if I am selling the electricity to the electricity board, then I will get 3 rupee 50 paise. That's what my assumption which I have taken. Let me go back to the wind turbine generator to model it. I am going for a catalog here. So here means the wind turbine generator rating from 1 kilowatt. Look at this. This is kilowatt to 7,580 kilowatt. That is 7.58 megawatt. The power is available. If you take 4,000, that is 4 megawatt power rating is available. So here directly you can see, I mean, what to say, the data is available. Enercon is now, which is wind gold, right? So I mean, similarly means some data is available by default in this website, and if you, I mean, what to say, couldn't find your case, like if you are taking, say, example 2000 kilowatt and that is 2 megawatt, and if you are expecting, say, Suslan, which is not available, you can develop your own library. There is an option called a library here in the top left. From the left, it is the fourth option. You can create your own library. So by default library, which I am using because of time constraint, but be assured that you will be able to means download the, I mean, what to say, create your own library based on the data from the manufacturer, right? So I have taken 2000 kilowatt, that is 2 megawatt. Let me take Enercon, right? So I have taken I mean, so to say, Enercon data, which is 2 megawatt, right? So I need to put up what is the capacity, what is the capital investment of it, right? Approximately means 1 megawatt will be in the range of about 5 crores to 6 crores. That's what the cost of the wind turbine. If anybody else has a much better number, that definitely can means what to say, you can really very well means what to say, update the cost. But in my view, approximately 1 megawatt will cost around 5 crores to 6 crores. So means 2 megawatt is a capacity what I have modeled. So I'm just putting, say, 10 crores, assuming 5 crore per megawatt, 100,000, 10,000, 1 lakh, 10 lakh, 1 crore, 10 crore. Yes. So I'm not going to replace it. Assume, say, means what to say, 2 lakh 40,000 as my maintenance cost. I am putting a maintenance engineer, and probably assuming maintenance engineer cost is the only cost, but definitely means what to say, there are other costs, overhauling cost, etc. But I am not including that. But you can, if you want, you can put it. Okay. So now if I look at this, I mean, so to say, what's the lifetime? What's the hub height? That's most important, right? You have seen depends upon the height, the potential has changed. Like means what to say, at 50 meter you have only 5,000 or 6,000 megawatt wind potential in Ladakh region, which I have shown from NIWE presentation. That is increased to 695 gigawatt in at 120 meter height level. So means your hub height is absolutely important, right? And if you look at the advanced data of wind turbine generators, yeah, you can model this power output curve. This is what one of my slide also has talked about, right? I believe, yes, somewhere we have seen some graphs, right? Yes, this is a graph. So means what say, this is not a generic data. This is a manufacturer specific data. You have to get the actual data and you have to feed it here in the simulation software, right? And what's the turbine losses? What's the maintenance table? That you can add if you have a maintenance schedule, predefined maintenance schedule. How many hours? What's the downtime? Everything. What's the cost? All this data which you can add, right? Fine, perfect, done. Fine. Now I think I have connected a wind, but you can look at this calculate button is disabled. Calculate button is disabled for a simple reason, because I means what to say, I have grid, I have a wind, but unfortunately I have not given what is the wind velocity which is available at that particular location. For that, what I need to do, I need to go to resource. I need to go to resource. Probably the component is just a component. This is a wind turbine generator of 2 megawatt from Enercon. That's it. So this is a grid which is available to extract the power from that. That's it. So if I want to understand what is the wind velocity at that particular place, I have to go to resource and I have to go to wind. So it's really important, before I am downloading the data from internet, I have to set what is the altitude above sea and what is the anemometer height. That's most important, right? So I have an 85-meter hub height. So I means I need to give what is the height at which I am measuring the wind, because wind velocity changes. Yes, right? And what is the mean sea level that I need to look at? Probably Chennai. Means you can put it Google Chennai or SRM Cotton Gulathur from mean sea level. What's the altitude? That might be means very close, because it's pretty close to the seashore, right? So I'm just giving 10 meters, but you can find it out, right? What is the mean sea level in Google at that particular location, right? So I have just given a 10 meters. Then I am downloading from an internet. Yes. So I have downloaded a data from an internet. This gives the annual average meter per second is 4.08. This is the data which comes from some sources which is there here, right? NASA Surface Meteorology and Solar Energy Database. Wind speed at 50 meter above the surface of the earth for terrain similar to airports. Monthly average values for a 10-year. Data of 83 to 93, right? This is the data. So this is where I have told, means National Institute of Wind Energy has precisely measured this data for the past few years. So in that case, means you should not use download from internet. Instead, what you need to do, you have to import. That means if you ask NIWE, if you are putting up a wind farms, they will give you the data. Okay, the measured data. That data you have to import. So what's the point which I am trying to stress? You have two options. One is directly to download from internet, another one is import, right? So import, you have to just import it. So means this import data should be accurate. As I told, means NIWE, National Institute of Wind Energy, has much accurate data. So since I don't have the data, I'm just measuring, means directly downloading from internet. That is the data from NASA, but please be remember that data is not really so to say correct data, because probably you can look at, means my hub height is about 85 meters, but that data has given at 50 meter height. So means you need to really look at means the data of validity of the data. That has a very significant role to play, right? So now probably the calculate button is enabled. Yes, let me go ahead with the calculating. Yes, the engine will take some time to simulate, but anyway, before that I will go for some questions. Yeah, question is, can you use the same software to solar system? Yes, you can use it, not necessarily for a wind, not necessarily for a solar, any source which you can use. Wind, solar, diesel, biomass, gas, hydro, any source which you can use. That is to answer a question, Rutaj. Yeah. So, let me take other questions, but anyway, I got the results. Yep. So, feedback form will be shared at the end. Yes, madam, thanks for the information. We will upload that feedback form at the end of the sessions. Do we have a data sheet or a manual to explore software fully? The software probably means I have given the link Homer. So means what to say? You can download the software. So in the software itself, organizing many means what to say video lectures, seminars, etc. And in fact, means they had a virtual conference for the last 2 3 days exploring. That comes at midnight because that's a US time, but still that means videos are available in YouTube which you can watch. The software has means what to say big capacity, and they have some help files which is available directly in the in software itself in a help file, right? Fault analysis with the grid integration of wind energy, that yes, to answer it, Uttara, that will be covered as a part of tomorrow. So we had a low flow, short circuit and power quality analysis using ETAP. That's tomorrow. That's to answer question Uttara Narasimhan. Yes. Homer Pro is only for wind or solar. No, Homer Pro is for everything. Any source you can model, as I keep repeating, gas, hydro, thermal, any source you can model. Yes, I believe that's all the questions. Yes, and in the meantime, I got the results as well here. Yeah, thank you. Thanks for your questions. And if you have any questions, you can really put it that. Yes. So answer is quite simple and straightforward. If I invest a 10 crore and invest in means what say 2 megawatt Enercon E82 E2 wind turbine generator, means my capacity factor is only 11.5 percentage. What's the meaning of it? That's not really worth. And levelized cost of energy is approximately in the range of about 3 rupee 97 paise. That's still okay because they are buying the electricity at 8 rupees. That's fine, but that's not really great because the plant utilization factor is quite less. So that's the real reason why, I mean, what to say, citing the renewable is really important. So instead of probably SRM Cotton Bluetooth, can you just name any perfect locations for the wind turbine generators, or can you just tell in India means which region has the highest wind potential? Yes, I'll look at if any other questions is there in the chat box. I will take it up. But meantime, if anybody has answered, what's the location which we have means what is it? What's the location which we have highest wind potential? Yeah, to answer question, Prakash, or any platform to learn Homer, means we generally suggest the people to learn the software on your own. That's how I have learned the software. I am using the software for the past 6 7 years. I have learned the software on my own. But yes, if you want some support on this, you can really contact us. Yes, you can contact us. Yes, Paul Raj, the Udumalpet, Kayatar, yeah, Gujarat. Yes, all these locations which you can model. Ladakh. Yes, okay, fine. So I have put it now. That's great. Okay. Palayamkota, Tirunelveli pass. Yes. Tamil Nadu, if you look at, you have three passes. So that's like I mean, let's say Palkat pass, and other one is Aralvai Mali and Kaikar pass, Tirunelveli pass, etc. So means that helps you to model. But anyway, I will take up only any one location. I will take a few questions. Can we cover the detail on ETAP also? I mean, tomorrow we are going to cover, that is to answer Samit Patel, we are going to cover ETAP modeling of this wind turbine generators tomorrow, not today. Uh, Rutaja, sir, is the software easily available or we want to purchase? The software demo is available that you can download. I have, if you have not watched this video, you can watch this video again, which is available in our channel. So we have given the link also to download the software. Software is available for free for 21 days. After that, if you want, you can buy it. The software will cost approximately about $1,000 for 1 year license. Uh, Sarada Devi, in the software, is it possible to use power conditioning device, any specific algorithms? No, means what say power conditioning device you cannot use, but you can use bidirectional converters. This is a software which just generally focus on the energy. So means here you cannot do any technical analysis or technical evaluation. You cannot do. That means if you want to look at the power factor, if you want to look at the voltage regulation, if you want to look at means the sudden drop in the wind, how this power is compensated from other sources, that you cannot compensate. That you cannot. I mean, what is validate using the simulation software. This is just benchmarking the energy only. Okay, fine. So for that, Sarada Devi, you have to go with the simulation softwares like DIgSILENT Power Factory. That's what we are going to cover on Saturday. Sine loop, where can we get the data files to import? Yeah, this data, as I told, means what is the institutes like National Institute of Wind Energy, etc., providing the data, which I have again shown it in the website. You go to their home page, means what's the measured data? Not necessarily for all locations, but different locations it will be available. Yeah, Kadiravan annual average wind speed is within 4 to 4.5 meters per second for area around Chennai. That's great, Kadiravan. He's working in. I have to acknowledge you. Yeah, G. Kadiravan. He's one of my close friend. He's working in National Institute of Wind Energy now, right? So his answer is probably perfectly all right. Means when I have modeled, means what say even before I have modeled it, he has told the average wind speed is in the range of 4 to 4.5. Exactly, we got the same, right? Uh, that's the reason why such people are there in some great organizations like me. Thanks, Kadrivan, for joining and adding the value. Yeah, I think all other questions has been answered. Yeah, I think any platform to learn, I believe I have answered that question also. Yes. Udumul paid Paul Raj, I will try to model it, but yeah, I will not be able to take up all the requests because everybody has given many locations, right? Yes, fine, done, good. So let me change the location. So for that, I am going back to home. I am changing the location from Kalathur to say Kayathar, right? You can model, please be remember, you can model any location. It is not necessarily a Kayathar or SRM Cotton Gulathur. You can model any location. You means I generally tell this is a session which is a beginning. You need to build up from the sessions. Please, I mean, sort of say, I cannot make you expert in a day. So means you have to practice the simulation software. Probably at the end of the session, I will share my contact numbers. If you have any difficulty, yes, probably you can reach out. So I have changed the location from SRM Cotton Gulathur to Kayathar, and I am just going back and I am trying to download the data with respect to the Kayathar. So you can look at what's their annual average. So definitely it has increased. Right now, let me run and find out what is the capacity utilization factor. You can see means 4.06 is the meter per second average velocity in Chennai, whereas it is 5.17 in Kayathar. And again, please be remember, as I told, this data is a very vague data. So this data is not necessarily has to be reliable. For that, like if you contact Kadiravan, who is already chatting, right? So means what say he will be able to provide you support you from many aspects, right? So if you put the wind turbine generator of this 2 megawatt in Kayathar, then the capacity utilization factor is 21.3%. That means what's the energy per year with the same wind turbine of means which you have installed a 2 megawatt, how much energy which you can generate and how much capacity utilization factor you can get is quite higher. So this is the impact, and it means even I have not really stressed more things. It means I have to touch quite a lot of points if I start touching it. So one thing what I need to touch is means what is the location. Second one means what's the wind turbine which I need to select, whether the hub height of 85 meters or 50 meters or 120 meters, right? So let me take some other wind turbine generator there, means in the same location, right? So let me take maybe another wind turbine generator and let's see whether that makes the same utilization factor, right? And I'm choosing from the same manufacturer, right? But that hub height is 122 meters, right? So if I go with that, right, means what to say, you need to really, I mean, this is the significance of the software. Means what to say, you need to have a right hub height, right? So means what to say, if I am going with both the wind turbine generators, you can find out what's the capacity utilization factor of both. So for a 2 megawatt, it is 21.3%. For a 3 megawatt, it is means what to say, what's the capacity factor? Capacity factor is 27.1. Right, so means what to say, it is really important you have to identify right hub height and the selection of the right wind turbine generator, right? So means what I am talking about is quite less, right? Means it's the very beginning, that's what I can see. I will take a few more questions. Why capacity shortage is taken as 100%? That's the question for Patil. Yeah, that's a good question. I believe you have precisely watched what I am doing in the software. Okay. Yeah, here annual capacity shortage. This annual capacity shortage is applicable only when we have a loads. That means if I have a remote village don't have electricity, if I want to electrify that village, then probably I can accept 10% or 15% loss of load, because people have really worried about cost rather than quality. But if you're doing this project for a data centers or means what to say hospitals, then annual capacity shortage should be 0% because you will not accept any tolerance on the loss of power supply, right? So if you come to the grid and only with the sources, then the software will work only when you have given 100. Just a software input, nothing else. Okay, the software only to find out the approximate CUF. What are the other functions available? That's a good question from Ganesh Kumar. Yes. Yeah, I'll talk about more on that. So the software just not helps you to find out plant utilization factor. It's able to give you many informations. The information is like a cost summary. That means what's the capital investment which you have invested on first year. So I have not run here for a multi years, but if I have run for maybe 20-25 years, means what is the payback year on year, that I will get here. And cash flow year by year you will get the data, right? And economics, say, means if you have multiple options, it will help you to compare what's the economics, like what is the return on investment, what is the internal rate of return, what is the simple payback period, what is the discounted payback period. It helps all. And electrical, if I have multiple sources, means which source is generating how much power, which source is generating how much power, means how much power is given by the renewables, how much power by your gas or diesel, what's the pollution, what's the emissions, all these informations which will be able to give. It will be also able to give what is excess electricity which is excessively available but there is no demand, or what is the unmet electricity, what is the capacity shortage, what is the renewable fraction, all these informations which you will be able to get. And renewable penetrations you will get from instantaneous values, means what is it with respect to the load, with respect to the grid. And means what is the individual wind turbine generators. Here I have modeled only a wind turbine generator, so you are getting wind turbine generator data. Similarly, if you have modeled solar, you will get solar inverter data. If you have modeled biomass, you will get biomass. If you model diesel, you will get diesel, right? You will get grid data, right? Each and every month, means what is the energy sold, what is the energy purchased, what is the peak demand, what is the energy charge, what is the demand charge, all will you get, right? So here means what is you are exporting everything. So means what is the net energy is in negative. That means it's only an export. And what's the emissions? Here emission is 0 because you are using pure renewables. If you have used a diesel or something, then probably you can means what's literally find out what's the emissions when you are using a diesel. That to answer a question from Ganesh, the software, is it only to find out the approximate CUF? No, the software help you to find out quite a lot. Like means you can find out a payback period. I mean, it's a commercial evaluation software. It helps from all the commercial perspective, like like here in the economics, which you can find IRR, ROI, simple payback, discounted payback. All these things it helps. And it's also means what to say, helps you to find out quite a lot of other technical informations, like how much energy comes from different source, what's the emissions, what is the cost, what's the approximate capacity of means it's an ideal software to select what should be the rating of individual sources. For example, if you have an industry, you have abundant land, and if you want to put up some sources, this helps to quite a lot. Means what should be the right capacity of wind or solar, what should be selected, etc. Yes, yes. Thanks a lot. Then I mean, I'm winding up the session today. Yeah. Thank you. Have a nice day.